Here we go. All right, so good morning. Welcome to Zoom conference for Thursday, April 2nd. We are going to be going over worksheet problems 7 and 9 using super grouping and factor with flip and slide. And then we will be going over our IXL practice. So if you're following along, starting off with number 7. So the trinomial here, 5x squared minus 23x plus 12. We're going to start by doing super grouping first. So off to the side here, we'll do super grouping. And then we'll do it again using flip and slide. So super grouping is essentially P's and Q's game with a little bit of a twist. So we start by writing it out, 5x squared minus 23x plus 12. And the way that this works is you're still trying to find two numbers that have a sum of the middle term. So it's what two numbers have a sum of negative 23. But instead of what two numbers have a product of 5, in this method, you multiply the first and the last term together. 5 times 12 is 60. And it's what two numbers have a product of 60. So that's the only difference when it comes to super grouping, is that the product is in P's and Q's is the product of the first and the last term. The sum is still the middle term. So once you've kind of set that up, then you play the game. So the question is, what times what equals 60, that when I add them together equals negative 23. You can only do grouping with 4 terms. So once you've found those two numbers, you're going to break up the middle term, get it into a 4-term polynomial, and then factor by grouping. So playing this game, what two numbers have a product of 60, sum of negative 23. So as I'm thinking about product of 60, I start maybe with like 6 and 10, but 6 plus 10 is 16. That doesn't work. 5 and 12. 5 plus 12 is 17, so that doesn't work. 20 and 3. 20 times 3 is 60. 20 plus 3 is positive 23, so just make both of them negative. So I know my two numbers here are negative 20 and negative 3. All right, from there, we take these two and we're gonna split this middle term into negative 20x and negative 3x. Order doesn't matter, you can also do negative 3x and negative 20x. So here we go, first term is still the same, 5x squared. Bring in negative 20x minus 3x, because negative 3x, and then bring down the last term plus 12. So again, in super grouping, you play the P's and Q's game, but you do it to split up the middle term. Now we can group. So what I notice here is that I do see subtraction. So when I put in my group, I want to make sure that I include that subtraction sign with the second group. So I put in like a little mini plus sign there. All right, from here, find the GCF of both terms. So 5x squared and 20x, I know have 5 in common. So this is 5 times x times x. And a negative 20x, if that's how I'm looking at it as, is 5 times negative 4 times x. So what do they have in common? They have a 5 and an x in common. 5 and an x in common. So that goes out in front. 5x, and then once I take out the 5x, what do I have left? Well, let's see. Take out the 5, take out the x from the first term, and that leaves me with x. Take out the 5, take out the x from the second term, and that leaves me with minus 4. Now, looking ahead, I know that x minus 4 is going to be my common binomial, so I need to try to get that over here as well. When the leading coefficient's negative, we have to factor out a negative. So what goes into negative 3 and positive 12? I know negative 3 does. So this is negative 3 times x, positive 12 is negative 3 times negative 4. So when I factor out negative 3, that leaves me with x in the first term, negative 4 in the second term. Doing a quick check, I know I'm on the right path because I have that common binomial factor. So in my final answer, I can pull that common binomial out in front, x minus 4. That's gone. What do I have left? I have 5x from the first term and minus 3 from the second term. And that leads me to my final answer using supergrouping. All right, same problem using slip and slide. So slip and slide is similar, but we're gonna do the P's and Q's game. So it's kind of nice that we already have it here, but it's gonna look a little bit different. Here's our goal for our answer. So starting off, we're gonna write it out, 5x squared minus 23x plus 12. So slip and slide. Step 1, we slip the first leading coefficient down to the end. So that's called our slip. And essentially what we're doing is we're multiplying 5 times 12. Very similar to what we were doing over here. Now we're working with a quadratic that is not equivalent to what we started with. So that's why I like to put it in quotations. Our new quadratic just became x squared minus 23x plus 60. But that's not actually equivalent, and that's where you have to be careful with slip and slide. These are not equivalent expressions. So now we play the P's and Q's game. What two numbers have a sum of negative 23, product of 60? Fortunately, we already played that game over here, and we know that those two numbers are negative 20 and negative 3. So from there, we're going to factor this out using P's and Q's. So we know our answer is going to be a product of two binomials like this. What times what is x squared? That's going to be x times x. And then what were our two numbers that multiply to 60 add to negative 23? Those numbers were negative 20 and negative 3. Now, this is not the answer. Instead, that was just when we flipped to get the final answer. You've got a slide, which means we're going to take the 5 that we flipped down to the end, and we're going to slide it underneath. Essentially, because you did multiplication, you have to undo that with division. So what does that look like? Well, that means we're basically dividing both of these second terms by that 5. And now we're going to go back into our original expression. So we're taking it out of quotations. Here's our final answer. We're simplifying the quotient if possible. And if we're not able to simplify the quotient, then we're rewriting it. So 20 divided by 5, we can simplify that. That's 4. So our first binomial is x minus 4. X minus 4, x minus 4. 3 divided by 5 cannot be simplified. So instead, think of it as we're going to rewrite this using almost kind of like MPO. We're multiplying both of these terms by 5. So if I multiply this by 5 and I multiply this by 5, that gets rid of the denominator. So this becomes just a minus 3, and this becomes a 5x. Or if that doesn't make sense, you just continue to slide it in front. Same answer leads me to believe that we did both of them correct. Okay, here we go. Number 9, again, from the worksheet practice, 5n squared minus 3n minus 8. This time we're going to do slip and slide first and compare it to supergrouping second. So for slip and slide, we start off with writing out the trinomial, 5n squared minus 3n minus 8. Oops, I just wrote 80, minus 8. Okay, step 1, flip. So flip means take the first leading coefficient, flip it to the end, and flipping just basically means I'm multiplying. 5 times negative 8. So that's our flip. Now from here, I'm working in quotations because I'm going to change what the expression actually has in value. I'm changing its value, I'm changing its appearance, and then I'll bring it all back together at the end. So once I flip that down, my expression becomes n squared minus 3n minus 40. Okay? By doing this, it puts it into a trinomial with a leading coefficient of 1. So whenever you have 3 terms, leading coefficient 1, you can just factor it using regular P's and Q's. So that means I can factor this, again in quotations because I did flip, so it's not the same. I know my answer is going to be a product of 2 binomials. I also know, without doing anything else, that the first term in both of these binomials is n, because n times n is how I get n squared. Now I just need to find the 2 second term, basically what times what is negative 40, but also adds to negative 3. So that's where the P's and Q's game comes in. So now I play the game, what two numbers have a sum of negative 3 and a product of negative 40. So I'm going to come over here and let's play it over here. So what times what is negative 40? That when I add them is negative 3. So you start just thinking about products of negative 40. So first one that comes to mind is negative 4 times 10, but I know negative 4 plus 10 is 6, and so there's no way of getting negative 3. Second one that comes to mind is negative 5 and 8. Negative 5 times 8 is negative 40. Negative 5 plus 8 is positive 3, so I know I'm close. Because I'm close, I just need to switch those. So instead of negative 5 and positive 8, what if it was positive 5 and negative 8? Let's see if that works. 5 times negative 8 is negative 40. 5 plus negative 8 is negative 3. I know I'm in the right spot here. Okay, so what's different here from supergrouping is I just get to take those two numbers, like normal P's and Q's, and I'm just going to put them into my expression. So now I know my first one is positive 5, my second one, negative 8. So all I did was normal P's and Q's factoring there. Final answer. I did my split. Now I have to do my slide. So I take the 5 from the front. I flipped it to the end. Now I need to slide it back underneath. Basically undo that multiplication with division. What does that look like? Well, if I can simplify the quotient, then I'm going to. And if I can't simplify the quotient, I'm just going to slide it in front. So now coming out of our quotations, getting into our final answer, my first binomial is 5 divided by 5 is 1. So n plus 1. Cannot divide negative 8 by 5. So think of it as you're multiplying both of these by 5. Or in other words, flipping that 5 out in front. 5n minus 8 is my second binomial. All right, same problem, supergrouping. Here we go. Supergrouping, lots of similarities to slip and slide. You end up playing P's and Q's, but the goal is different. So supergrouping, step 1, write it out. All right. So to play the P's and Q's game with supergrouping, very similar to slip and slide, where you flip this to the end, you're going to multiply the first and the last term. 5 times negative 8 is negative 40. And that is your product using P's and Q's. So now we play the game. What two numbers have a sum of negative 3, product of negative 40? So we already did this over here. So we know that those two numbers are 5 and negative 8. What's different between these two is that we're not factoring using 5 and negative 8. We're using 5 and negative 8 to break up the middle term. Our iRobot vacuum is stuck somewhere and it sounds like a pig going off. Okay, here we go. So now we rewrite it using 4 terms. Our first term is 5n squared. Second term is going to be a positive 5n because our P's and Q's was 5. Second term is going to be a negative 8n. So basically all we're doing is splitting up that middle term, and we bring down the minus 8 at the end. So now that we've split it up into 4 terms, we can go in and factor by grouping. So here we go. First group, and then because this is negative, I'm going to put a little plus sign in here and include a negative in the second group. Can you go see where it is and try to save it wherever it happens? We're going to do a rescue mission with our iRobot. Okay, now we do Gcf factoring. So I see 5 in both of these, which leads me to believe that 5 is the GCF. So 5n is 5 times n, or 5n squared, excuse me. Positive 5n is 5 times 1 times n. What do they have in common? they both have a 5n. So I factor out 5n, and then it's what is left behind. So after I factor out 5n, I'm left with n in the first term and 1 in the second term. So n plus 1. Already you might see the connection here that n plus 1 is going to be one of our binomials, which is good. I know I'm trying to get n plus 1 here too. So over here, I see 2 -8s. So I'm factoring out -8. That's -8 times n. -8 times +1 is how you get -8. So when I factor out a -8, that leaves me with n and a +1. Bring it all back together. Final answer. First binomial, n plus 1. Once that's gone, I'm left with 5n from the first minus 8 from the second. So there you have it. Same exact answer, 2 different methods. Okay, so general consensus is we're just going to focus on slip and slide from now on. So we're going to go over some IXL practice problems, only doing slip and slide. So here we go. Alrighty. Okay, first problem, if you're following along, go ahead, write it down. We've got 2u squared plus 9u plus 7. So, and again, we're only going to be doing slip and slide. 2u squared plus 9u plus 7, okay? I do know something already. I know that my answer is going to be a product of 2 binomials, and I can already kind of look ahead if you want to think about it like this. I know that the first 2 terms have to multiply to 2u squared. So I know the first one's going to look something like this, and the second one's going to look something like this, because I know that I have these 2 terms have to multiply to 2u, and these 2 terms have to multiply to +7. So just an idea, that's kind of what your answer is going to look like. Okay, so let's do slip and slide and factor this. Here we go. First step, flip. Grab the leading coefficient, flip it down to the end, and multiply it. 2 times 7, which is 14. So now we're working with a new trinomial, so it's in our quotations. Our new trinomial is u squared plus 9u plus 14. By doing that, we've gotten rid of the leading coefficient, which means now we can play the P's and Q's game and factor it. So I know my next step after this is I'm going to factor this trinomial. This will not be my final answer, but this will take me 1 step closer to finding my final answer. All right, play the P's and Q's game. What 2 numbers have a product of 14 and a sum of 9? So what times what is 14? When I add them together, I get 9. So if you're following along, try to find those 2 numbers. While I'm thinking about it, I know what times what is u squared. That's u times u. So now it's just play the P's and Q's game to fill this in. So product of 14. The only thing that comes to mind for me is 2 and 7. So let's see if that works. 2 times 7 is 14. 2 plus 7 also equals 9. So that's the value of P and Q. We can now take these and put them directly into our binomials. +2, +7. So just to make something clear, this is how you factor this type of trinomial. So if this was the question we were given, we would be done by now. But this is the question we were given, so our final step is slide. So we flipped, factored a totally different trinomial. Now we have to slide. So the slide step means you take that leading coefficient, 2, and we're going to slide it underneath both of these. Because it always has to do with the last term. I flipped it to the last term, so now I need to slide it underneath the last term. All right, going back to our original expression now, taking that out of quotations, let's simplify. 2 divided by 2 is 1. So I have u plus 1 Can't do 7 divided by 2, so I can continue to flip that in front, which basically means I'm multiplying both of these by 2, and that gives me 2u plus 7. Or another way to do this, you could also say it's 2u plus 7 times u plus 1. So we're going to pop over to IXL and see if that was correct. Hopefully it was, otherwise that's embarrassing. Our answer was u plus 1 and 2u plus 7. And it looks like we're good to go there. Okay, example number 2 from IXL, 2p squared plus 11p plus 9. So let's go over this one again using our slip and slide. Step 1, slip. Take the leading coefficient, flip it down to the end. This becomes 2 times 9, which is 18. So our quotation trinomial that we're working with now is p squared plus 11p plus 18. We know that's going to factor into 2 binomials. And we know that the first term in each binomial is going to be p. To find the second term in each binomial, we are going to play the P's and Q's game. So what 2 numbers have a product of 18? Sum of 11. What times what is 18? That when I add them together, I get 11. 6 and 3, add up to 9, 18 and 1, add up to 19, 9 and 2, add up to 11. So I know my 2 answers in any particular order are 9 and 2, or 2 and 9, doesn't matter. Take those, put them into your binomials. It's a positive 9 and a positive 2. Remember, that is not your final answer. Your final answer happens after you slide. So it's called flip and slide. So now that we've flipped, let's go ahead and slide that 2 back underneath. Now we have our final answer. So cannot divide 9 by 2 evenly. So that means we're sliding that 2 in front. 2p plus 9. Can divide 2 by 2 evenly. That gives us p plus 1. So 2p plus 9 times 2 plus 1, or if depending on the order that you did, if you put 2 here and 9 here, your answer would have been p plus 1 times 2p plus 9. Are those the same? Yes, they are equivalent. Order does not matter. Let's pop over to IXL and see if what we just did was correct. It does kind of match that original structure I was thinking of. P plus 1, moment of truth, and we did it. All right, here we go. Jump to level. So once you get to a SMART score of 43, you're going to have to start dealing with some negatives. So go ahead, write this one down and give it a shot. Here we go. Okay, going over this problem, doing flip and slide. So step 1, flip the leading coefficient down to the end. 2 times negative 2. Keep in mind that that is a negative 2. Now we put our new trinomial in quotations. That gives me w squared plus 3w minus 4. And I know my next step is a product of 2 binomials where the first term is w in both, because w times w is w squared. I like to set all of that up from the get-go. Okay. What 2 numbers have a product of -1 and a sum of 3? Not -1, -4. What is 3? Okay, so there's only 2 ways to get -4. That's -2 and +2, but those add up to 0, so that won't work. So remember, there is a number that goes into everything, and that number is 1. So it's either going to be 1 and -4. Let's try that first. 1 times -4. -4. 1 times -4 is -4, but 1 plus -4 is -3. So we're close. Whenever we're close, that usually just means you switch the negative to the other number. -1 times 4 is -4. -1 plus 4 is 3. So we're looking good. So I know my two numbers are -1 and +4, or you could put the +4 here and the -1 there. That doesn't matter. Flip is done. Factoring is done. Final step, slide and simplify. So I'm taking the 2, sliding it underneath, and simplifying where possible. So taking it out of quotations, putting it into a final answer. So cannot simplify 1 divided by 2 evenly, so slide that 2 in front. 2w minus 1 is my first binomial. Can do 4 divided by 2. 4 divided by 2 is 2. So w plus 2 is my second binomial. Let's see if what we did was correct. Oops. So my answer was 2w minus 1 and w plus 2. Submit, and we're good. Resume recording. Okay, jump the level up to 72. So these ones, once you get past 70, 72, that area, these are going to be different. So let me make something clear. I see something in this trinomial that shows me I'm actually not going to do slip and slide here. I'm not doing slip and slide. I'm not doing super grouping. I'm not doing double cross. So if you write this one down, I'll show you what I mean. And this is where things start to get a little bit more complicated, which is why this is obviously at a higher SMART score. So if I write this one down, 3h squared minus 24h plus 45. Here's what you need to start looking for when you get to a problem like this one. Again, I know I'm not using slip and slide here, and I'm not doing any of the methods that we learned yesterday. Here's how I know that. I look at 3, 24, and 45, and I realize that those three numbers have something in common, meaning basically that they have a common factor. So this is called fully factoring. So from this point forward, once you get up into that 70s range, you always want to look for a GCF. That becomes your first step going forward. So essentially, that means start testing whatever's out in front. Does that number also go into the other two terms? I happen to know that yes, 3 does go into 24 and 3 also goes into 45. So here's what we're gonna do. And then this actually, because we're gonna factor out the GCF, this will actually become a much easier problem to deal with. So here we go. We're gonna factor out 3. So that means in the first term, 3h squared is 3 times h times h. 24h is 3 times 8 times h. And 45 is 3 times 15. So in this case, the only number they have in common is 3. 3, 3, and 3. That's it. So I'm going to start by taking out 3 from all 3 terms. That means I'm left with 3 times, when I take out 3 in the first term, that leaves me with h squared. When I take out 3 in the second term, that leaves me with a minus 8h. And when I take out 3 in the last term, that leaves me with a positive 15. So that was GCF factoring. But here's the thing. If I take this and I put that into IXL, IXL will say that I'm wrong because I'm not fully done factoring. Because the trinomial that is now inside of your parentheses can be factored. This can be factored using P's and Q's. How do I know that? I know that because it has 3 terms and because the leading coefficient just became 1. So follow along here with what I do next. The middle term is the sum, and the ending term is the product. That's still the same. P's and Q's, sum and product. So now what times what is 15? That when I add them together, I get -8. I happen to know that those two numbers are -5 and -3. Okay, so watch and learn. Here's what I'm going to do. I'm going to factor this trinomial. So I know that this is going to be two binomials. And this is not slip and slide. So like I know that I'm going to be done at this point. However, this 3 from the original expression must be part of my final answer. Like that 3 is part of that product. It doesn't just go away. So I know in my two binomials that my first term is going to be H. According to the P's and Q's game, my second terms are going to be -5 and -3. And this is my final answer. If I don't include the 3, then this will not be accepted. So when I go over to IXL, if I, for example, just try to get away with doing H -5 and H -3 and click submit, it's going to tell me that I'm incorrect because I didn't include the 3 out in front. So with problems like these, they're a lot tougher because you have to realize that these all have a common factor. So at some point you need to start looking out for a GCF. Okay, so in this one, notice how my SMART score is a 66 and my expression is 5p squared plus 24p minus 5. This is not one that I would have to find a GCF for. Here's how I know. 5 goes into 5, but 5 does not go into 24. So because of that, I know that I would just use slip and slide here. This is not a trinomial that I would try to do a GCF with. But if I jump again above 72, that's when you have to start looking for it. Let's see on this one. Let's see, does 2 go into 11 or 5? Nope, so I don't have to do GCF factoring there. Let's see if I can find another example where I have to do GCF factoring. Ah, this is a perfect example. So this one stands out to me because the leading coefficient is 5, and I know 5 goes into both 25 and 70. So this is an example where I'm going to have to do GCF. Slip and slide would not work here. So we have 5t squared plus 25t minus 70. Okay, so we'll go over this one together. This will be our last example for this afternoon. Okay, look for a GCF. As we already mentioned, 5 does go into 25 and 70. That means 5 is our GCF. So that's what we're going to factor out. So again, we are not doing slip and slide or super grouping or double cross on something like this. So writing out using 5, this is 5 times t times t. This one is 5 times 5 times t. Negative 70 is 5 times 12 is 60. So 5 times 13 is 65. So size of 14. All right, so once I factor out that 5, that leaves me with 5 times a trinomial. Take out 5 from the first term, that leaves me with t squared. Take out 5 from the second term, that leaves me with 5t. Take out 5 from the last term, that leaves me with minus 14. We are not done. If I try to type this into IXL, they will say that I am wrong. That's because I now have to factor this using P's and Q's. How do I know? 3 terms, leading coefficient just became 1. Now I'm going to plan ahead. That 5 doesn't go away. It's still going to be there. But this trinomial is going to turn into a product of 2 binomials. I also know that the first term in both of these binomials is t, because t times t is how I get t squared. Now we play the game. What 2 numbers have a product of negative 14 and a sum of 5? So what times what is negative 14? But when I add them, I get 5. 7 and 2 come to mind. So it just becomes which one's positive and which one's negative. So let's try negative 7, positive 2. Yes and no. Negative 7 plus 2 is negative 5, which is close. So let's try 7 and negative 2. Yep, that works. 7 times negative 2 is negative 14. 7 plus negative 2 is 5. So I'm going to put positive 7 here, negative 2 here, and this is fully factored. I took out the GCF, put it out in front, and then I factored using P's and Q's with what I had left. So over here in IXL, make sure again that 5 goes out in front, followed by your first binomial using P's and Q's, and your second binomial using P's and Q's. Hopefully that works. And there you go. So notice once you get into a SMART score of 90s, which is definitely above and beyond, you're going to have to deal with some larger numbers. Here, this is probably telling me that 7 does go into 91 and 98. So just to kind of quick review, everything leading up to this point, if I jump back a level, this is something I would not do GCF factoring with, because 2 does not go into 3 or 5. So I would use slip and slide here. But as soon as I get to level 70 and above, I know that 6 goes into 72 and 78. Know how I know is because the numbers get bigger. And as the numbers get bigger, there's a greater chance that there's going to be a GCF. So in order to get that full score, you will have to do GCF factoring at some point. So today's assignment is an IXL code. The code is 7ED, and that will be posted on Google Classroom. In addition to that code, make sure that you are at least attempting the worksheet practice from yesterday and filling that attached survey out. And then tomorrow we will have homework help as well, in addition to everything else. So email me with questions and have fun factoring.